So if you have the empirical formula, multiplied by some factor will give you the molecular formula mass. So how you can calculate N? Molecular mass divided by empirical formula mass. If you calculate, you can get N. So once you calculate or get the value, if you take the inverse of that, you will directly get the value for wavelength. So if you know this equation, you don't have to worry about the hydrolysis of sucrose, just you have to substitute the values. So what is that you have to calculate? Delta G naught you have to calculate, right? So now what is R value? R value is already given in the question, that is 8.314, okay? Hello everyone, this is Amli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today I am back with session 4, that is the last session of the model question paper. So in today's session, we are going to discuss the last part of the question paper, that is part E, that is just for the numericals, right? So each of this numerical will carry 3 marks, right? So answer any 4 of the following, each question carries 3 marks. So 4 into 3, you will get 12 marks from this section, right? Okay, so you have to attend any 4 out of these questions, okay? Each one will carry 3 marks. So part E, as I said, it is exclusively for numericals. So you won't find numericals in any other part, that is from A to D, numericals won't be there. E part is only for numericals. Let's begin with the first one. An organic compound contains 26.66% carbon, 2.22% hydrogen and 71.12% oxygen. Okay, the molecular mass of the compound is 90. Find molecular formula. Okay, so you have to find the molecular formula. Certain given things are there. Okay, so the organic compound contains how much percentage of carbon, hydrogen and oxygen it is given, it is written. So first what you have to calculate the number of moles. So how do you calculate the number of moles? That is mass by molar mass. So which are the atoms which is given here or elements? Carbon is there, hydrogen is there, oxygen is there. So how do you calculate the number of moles? You already know the percentage, that is 26.66 is for carbon divided by the atomic mass, which is 12, right? To 26.6 divided by 12 will give you 2.26. So this is the number of moles of carbon. Now number of moles of oxygen, how do you calculate? What is the percentage given for oxygen? It is 71.12 divided by what is atomic mass of oxygen? It is 16, which will give you 4.44. Now the next one is for hydrogen, that is number of moles of hydrogen is 2.2. It is given 2.22% divided by 1, right? Atomic mass of hydrogen is 1. So that will give you 2.2. So this is the first step, that is you mention the elements, right? And you know the percentage divided by their respective atomic masses, you will get the number of moles. Now you have got the value 2.216, 4.44, 2.2. So now out of these 3 values, you have to find out which is the smallest value out of these 3. You have 2.2, 2.2 and 4.4 here. So which is the smallest one? Of course it is 2.2. Okay, so it is 2.2 here also. So after getting the values, you have to see which is the smallest among those 3. Right. Now, with that smallest value, you have to divide all the other values. That means 2.2 is the smallest one, right? So here you have to do 2.2 divided by 2.2. Here you have to do 4.4 divided by 2.2. And here again you have to do 2.2 divided by 2.2. So this will give you 1, this will give you 2, this will give you 1. So what will be the ratio? It will be 1:2:1. So simple whole number ratio of moles of carbon, oxygen, hydrogen will be 1:2:1. I hope it is clear. Number of moles you calculate. Out of the number of moles, which one is the smallest one? Divide that value to each of the number of moles which is calculated. You will get a simple whole number ratio. So, from that simple whole number ratio, you can calculate first the empirical formula. So, what is the ratio of carbon? It is 1. Oxygen, it is 2 and hydrogen, it is 1. So, that means you can write it is in this format, that is CHO2. Okay, oxygen you have 2, right? That is why CHO2. So, this is the empirical formula. Okay, so this is the first part. Now, what you have to do? Molecular mass is already given here. Okay, so molecular mass is already given. We know the empirical formula also. So, you can calculate the empirical formula mass. Okay, so how do you calculate the empirical formula? Mass. It is for carbon, atomic mass is 12. For hydrogen, it is 1. And for 1 oxygen, it is 16 atomic mass. So 2 oxygen, 16 into 2, it will be 32, which will give you 45. So this is the empirical formula mass. So once we get the ratio, we calculate empirical formula. From that empirical formula mass, we can calculate. Add the atomic mass of each of the element which is present. You will get the atomic, that is empirical formula mass. Then molecular mass is already given here, which is 90 gram. Now we have to calculate the N value. That means molecular formula will be empirical formula into some value. So if you have the empirical formula multiplied by some factor will give you the molecular formula mass. So how you can calculate N? Molecular mass divided by empirical formula mass. If you calculate, you can get N. Right? See, molecular formula is equal to empirical formula into N. So what is N? This divided by empirical formula, right? So we already calculated, we already have in the question what is the molecular mass. It is 90. Empirical formula mass we just calculated, it is 45. So you got the value of N as 2. Then how you can calculate molecular formula? It will be empirical formula into N. What was the empirical formula? N is what? 2. We just calculated CHO2 times 2. So that means carbon 2, hydrogen 2, oxygen will become, already 2 was there, now 2 also. So it will be C2H2O4. So this is the molecular formula. So I hope it is clear. Moving on to the next question. Dinitrogen and dihydrogen react with each other to produce ammonia according to the following chemical equation. So the balanced chemical equation is already given. Nitrogen plus 3 moles of hydrogen combines to form 2 moles of ammonia. So calculate the mass of ammonia produced if 2 into 10 to the power 3 gram nitrogen reacts with 1 into 10 to the power 3 gram of dihydrogen. Okay, so these are the given. So what is that you have to calculate? You have to calculate how much ammonia, what is the mass of ammonia produced if 2 into 10 to the power 3 N2 and 1 into 10 to the power 3 H2 is present. Okay, so first from where do we start? Before going on to the given things, what we have to do? We have to go to the balanced chemical equation which is already given. If it is not a balanced chemical equation, you have to balance it. That is your first step. So it is already given a balanced chemical equation. Okay, so from this balanced chemical equation, what are the things that you can calculate? See, here only 1 mole is there. So it is 1 mole of nitrogen which combines with 3 moles of hydrogen to form 2 moles of ammonia. So this is one thing we can understand from the given equation. Another one is based on their atomic mass or molecular mass we can calculate. So for one nitrogen the atomic mass is 14. So for N2 it will be 28 gram, right? And for hydrogen atom it is 1, hydrogen molecule it is 2. So how many moles are there? 3 into 2, it will give you 6 gram. Okay, so 28 gram of nitrogen will combine with 6 gram of hydrogen to form ammonia. How do you calculate molecular mass of ammonia? For nitrogen it is 14. For each hydrogen it is 1, so it will give you 3, which will give you 17 gram. That is for 1 mole of ammonia. Now, how many you have? 2. That is 17 into 2. That will be 34 gram. So, another way also we mentioned it. That is 28 gram of nitrogen will combine with 6 gram of hydrogen to form 34 gram of ammonia. So, we have in the question now. So, this is based on the equation which is given. Now, let's go to the question. Calculate the mass of ammonia produced. You have to calculate how much ammonia is produced when 2 into 10 to the power 3 nitrogen and 1 into 10 to the power 3 gram of hydrogen is present. Okay. So now from the balanced chemical equation, we know that if 28 gram and 6 gram of hydrogen is there, you will get 34 gram of ammonia. Okay. 28 gram of nitrogen requires 6 gram of hydrogen to produce 35 gram of ammonia, which is already known. Now, if that is the case, that is 28, we are only considering nitrogen and ammonia now. Okay. So 28 gram of nitrogen, if we are using, we will get 34 gram of ammonia. So this is from the equation. So now we have to see how much ammonia is produced when we use 2 into 10 to the power 3 gram of dinitrogen. That is, instead of 28, if I have 2 into 10 to the power 3, how much ammonia is formed? So how do you calculate that? Now I have 2 into 10 to the power 3 nitrogen, that is 34. This value divided by 28 into this value, that is 2 into 10 to the power 3. If I do, I'll get how much ammonia is present, that is it. So 35 divided by 28 into 2 into 10 to the power 3. So if you calculate, you get 2.43 into 10 to the power 3. If you include this 10 to the power 3, the decimal point will change to 2430 gram of ammonia. So this I have discussed in terms of nitrogen and ammonia. You can also do it in terms of hydrogen and ammonia also. That means you know that 6 gram of hydrogen will give me 34 gram of ammonia. Right. Now, if that's the case, 1 into 10 to the power 3 gram of hydrogen, if I am taking, what will happen? It will be 34 divided by this value, divided by 6 into 10 to the power 3. So, that will give you the mass of ammonia, which will be the same itself. So, I hope it is clear. Right. Moving on to the next question, 47. Calculate the wave number and wavelength of first line in Balmer series of hydrogen spectrum. So, RH value is already given in the question. So, calculate the wave number. What is wave number? Nu bar, right? Wave number you have to calculate. Wavelength also you have to calculate. That is lambda of first line in Balmer series. So, first of all, you need to know what is Balmer series, right? So, we have studied line spectrum of hydrogen. So, Balmer series means the N1 value. So, first of all, we need to know the equation that we have to use. That is nu bar is equal to RH into, this is a constant, right? It is Rydberg's constant into 1 by N1 square minus 1 by N2 square. So, this is a constant which the value is already given. So, it is given that we have to calculate nu bar and lambda for first line in Balmer series. So, it is given in the question itself. It is Balmer series means you should be knowing what is the N1 value. N1 value for each series is specifically given. For Lyman series, N1 will be what? 1. For Balmer, N1 will be what? 2. For Passion, it will be 3. Bracket, it will be 4. Fund, it will be 5. So, this is the order. So, for Balmer series, of course, it is 2. So, in place of N1, we substitute 2. N1 square, instead of that, we put 2 square. Now, it is given first line in Balmer series. So, what will be the first line? If you have to get the first line, imagine this is the line spectrum which is shown here. This stands for N1 is equal to 1. This is 2. This is 3, 4 and 5. So, this is the Balmer line that you can see. N1 is equal to 2. So, from any higher level, if the radiations is coming back to the second level, it is called as Balmer series, right? So, which will be the first line in Balmer? That will be from 3 to 2. Right. It can be from 4 to 2. It can be from 5 to 2. It can be from infinity to 2 also. But which is the first line? It will be from 3 to 2. That is why we are taking the N2 value as 3. So, they have not directly given you the N1 value and N2 value. You should be able to calculate what is the N1 value and N2 value. N1 you can directly calculate from Balmer series. Balmer means N1 will be always 2, right? And first line means that this will be the first line, of course, right? So, N2 will be what? It will be 3. So, it will be 109677 is the same value that 10 to the power 7 we have taken inside, that is. So, 1 by 2 square minus 1 by 3 square. What is 1 by 2 square? That is 1 by 4 minus 1 by 9. Now, what is 1 by 4 minus 1 by 9? I'll just write it down here. 1 by 2 square minus 1 by 3 square. That is 1 by 4 minus 1 by 9. So, if we take the LCM, it is 9 minus 4 divided by 36, which is 5 by 36, which is shown here. 109677 into 5 by 36. So, if you calculate, you get 15232.9 centimeter inverse. So, writing the unit is also very, very, very important. Okay. So, this is the value. So, what is the value you have calculated? It is nu bar what you have calculated. Nu bar means what? Wave number. So, if you have the wave number in your hand, it is very easy to calculate wave length. So, what is the relationship between wave number and wavelength? It is nu bar is equal to 1 by lambda. So, you already calculated wave number. So, if you take the inverse of that, you get the wavelength, right? So, lambda is equal to 1 by nu bar. So, this value, the inverse of it will give you 6.565 into 10 to the power minus 9. So, 10 to the power minus 9 is the prefix for nanometer, right? So, you can write it as 656.5 nanometer also. So, this is the wavelength and this is the wave number. So, this is the equation which is given for wave number. Okay. So once you calculate or get the value, if you take the inverse of that, you will directly get the value for wavelength. Okay. So what is important in this particular problem is that you should be knowing Balmer series, what is the N1 value, and is given that first line means N2 will be 3. So that you have to understand. Clear? Moving on to the next question. That's question number 48. Calculate the energy of 1 mole of photon of radiation whose frequency is 5 into 10 to the power 14. Okay. So first of all, if a numerical is given to you, what and all you should write? You should write the given things. Okay. What and all is given in the question, you write it down first. Then you can substitute in the equation which is required. Okay. So energy of photon. What is the equation for energy we have studied? E is equal to h nu. Right. E is equal to h nu. Okay, so energy we have to calculate. So that's a part. Calculate the energy of 1 mole of photon. Okay, so what is the value of H? H is Planck's constant, which is a constant value. It can be given in the question, it cannot be. So you have to be very clear with that value, which is 6.626 into 10 to the power minus 34, which is the value for H, right? And new value, frequency. Nu stands for what? Frequency. It is already given 5 into 10 to the power 14, which will give you 3.13 into 10 to the power 19. Okay. So we are substituting in this equation 6.626. H stands for Planck's constant minus 34 into what is the frequency value? It is 5 into 10 to the power 14. So how do you do this calculation? You can do 6.626 into 5. Okay, together, and you have 10 to the power minus 34 and 10 to the power 14. Okay, so two 10 to the powers are there, you have to just add it, that is minus 34 plus 14, which will give you minus 20. Okay, so this will be 6.626 into 5 into 10 to the power minus 20. So once you do this, finally, that is this part also you have to multiply. So you will end up in this equation. So this is for energy of the photon. But one more part is necessary. For 1 mole of photon, you have to calculate. So it is necessary to multiply this value with Na, that is Avogadro number. Okay. So energy of 1 mole of photon is Na into h nu. H nu we have already calculated. So that means for 1 mole of photon, it will be 6.022 into 10 to the power 23, that is Avogadro number, into this value 3.313 into 10 to the power 19. Okay, so if you do this, you will get 199.542 kilojoule per mole. That is the unit for energy. So I hope it is clear. Okay, so it is very important. This equation you will remember E is equal to h nu, but it is important to multiply the value by the Avogadro number also, because it is asked for 1 mole of photon. I hope it is clear. Moving on to the next question. 49. The standard enthalpy of combustion. So what is combustion? That is the compounds which is containing carbon. It burns in presence of excess of oxygen to produce carbon dioxide and water, right? Okay, combustion of carbon, hydrogen and C6H6. What is C6H6? It is benzene, right? And the values are given as minus 393.5, minus 285.83 and minus 3267 kilojoule per mole, okay, respectively. Calculate the standard enthalpy of formation of benzene. So you have to calculate the standard enthalpy of formation of benzene from the given values, okay. So first what we have to do is we have to find out which is the required equation. That means, what is the equation to calculate the standard enthalpy of formation of benzene? That means how the benzene is formed from these three combustion equations which is already given to you. Okay. So how do you obtain the required equation? We need benzene. So which are the compounds or which are the elements which is present here? Carbon, hydrogen and benzene is present, right? So we have to produce benzene, or the formation of benzene we have to write an equation. So you know that carbon has to combine with hydrogen so that it forms benzene. So this is the equation that I basically need, that carbon and hydrogen will combine and I'll get benzene. But now I have to balance this equation. So you have 6 carbon atoms, so I put 6 here. You have 6 hydrogen atom, I put 3 here. That's it. Your equation is balanced. So this is your required equation. 6 moles of carbon plus 3 moles of hydrogen combines to form benzene. Okay. So this is the first step. You need the required equation. So it is given enthalpy of formation of benzene. So you need to find out an equation from carbon and hydrogen how you can form benzene. So just balance it. So this is the equation. Now what is given? the enthalpies of combustion of carbon, hydrogen and benzene are given. So first we have to write the combustion equations. First the combustion of carbon. That is carbon plus oxygen gives carbon dioxide. This is the equation for combustion of carbon, which is carbon burns in presence of excess of oxygen to form carbon dioxide. The enthalpy value is given in the question already. Now the next one is combustion of hydrogen. Hydrogen combustion means oxygen, right? It produces what? Water. So after balancing, you will get a half O2 here. So it's just basic balancing. Now the next one is combustion of benzene, right? Again, benzene combines with oxygen to form carbon dioxide and water. After balancing, you will get this equation. So these values are already given in the question. Okay. So this is the value of combustion of benzene, combustion of carbon and combustion of hydrogen. So this much is what you have to do first. Required equation you have to write and the equations which is already given in the question. So in here, these three equations were already not given, but you have to form the equation. But in certain cases, the three equations that you need will be already given in the question also. Okay. So now we have to see these three equations and make necessary adjustments so that I obtain this equation. So that is basically what I have to do. So you can see carbon is present on the reactant side. So you have carbon on the reactant side in second equation. So there is nothing much I have to do in the second equation. So you can see here carbon is on the reactant side in the required equation and you can see carbon is in the reactant side in the given equation also. But you can see 6 moles of carbon is required, but you have only 1 mole of carbon here. So what do you have to do with the second equation? Second equation you are going to multiply by 6. So that you get 6 moles of carbon here, which is equal to the required equation. So second equation, what you are going to do? Multiply by 6. So if you are multiplying the second equation by 6, what happens to this value, enthalpy value? That will be also multiplied by 6. That is minus 393.5 into 6 it will come. Clear? Now moving on to the next one, you have hydrogen on the reactant side. So here also you have hydrogen on the reactant side, nothing to worry. But you have 3 moles here. You have only 1 mole. So what you have to do? You are going to multiply this particular equation by 3. So that you get 3H2 which is equal to the required equation. So if you are multiplying the equation by 3, the enthalpy value also it is multiplied by 3. Okay. Now the last one, here on the required equation, benzene is on the product side. But here in the given equation, benzene is on the reactant side. So what you have to do? You have to reverse the equation. Okay. So this will become the product and that will become the reactant. So if you reverse the equation, what will happen to the enthalpy? Here you have minus 3267, it will become plus 3267. I hope it is clear. Okay. So what we are in total doing? Equation 2 we are going to multiply by 6. Okay. And equation 3 we are going to multiply by 3. Okay. And equation 1 what we are going to do? It is going to be reversed. So when you are reversing, it is very important to remember the sign also has to reverse. Okay. So what happens? See, the first equation what we have done, we have reversed it. So the enthalpy has become plus 3267. Clear? Now, the second equation, if we multiply by 6, it becomes 6 carbon plus 6 oxygen gives 6 carbon dioxide. So the value also we have multiplied by 6. Clear? Now the next one is multiplied by, the third equation is multiplied by 3. So 3H2, 3 by 2. 1 by 2 into 3 is what? It is 3 by 2. So 3 by 2 O2 gives 3H2O. So that value is also, that is, this value is also multiplied by 3 which will give you minus 857.7. So now what is the next step? If you add all these three, are you going to get this? We are going to see. So you have 6 carbon dioxide here on the reactant side. On the product side also you have a 6 carbon dioxide. So you can cancel these out. In the reactant side and product side it is there. So it cancel out. Okay. Now you have 3H2O on the reactant side. Do you have a 3H2O on the product side? Yes. So that also cancels out. Now what is there? 6 carbon atom is here. Any other 6 carbon atom? No. You have 6 oxygen atom here and another 3 by 2. You have 6 O2 and another 3 by 2 O2 on the reactant side. And do you have any other oxygen in the product side? Yes, you have 15 by 2 O2 on the product side. So this, if you take the difference, you'll get to know. So 6 plus 3 by 2 is what? 6 into 2 is 12. That will give you 15 by 2 O2. So now if we add this and this, you will get a 15 by 2 O2 which is on the reactant side, and on the product side you have a 15 by 2 O2. So altogether it will get cancelled, right? Now what are the only things that is remaining? You have 6 carbon atom. You have 6 moles of carbon, you have 3 moles of hydrogen, and you have your benzene. So that is how you obtain the final equation. So that is how we ended up in the required equation. But what is that we are going to do here? We are going to add all these values. 3267 minus 2361 minus 857.7, which will give you plus 48.3 kilojoule per mole. Okay, so as the enthalpy value is positive, we get to know that it is an endothermic reaction. So I hope it is clear. So this is how you have to do this calculation. Now moving on to the next question, that is question number 50. Calculate the total work done when 1 mole of a gas expands isothermally and reversibly from an initial volume of 10 decimeter cube to final volume of 20 decimeter cube at 27 degrees Celsius. R value is given in the question. Okay, so it is given that you have to calculate the total work done, and 1 mole of ideal gas, it is also given, expands isothermally and reversibly. So isothermally and reversibly, what is equation for work done? It is minus 2.303 nRT log V2 by V1. So this is the equation that you have to use. Okay, so what are the given things? You know, it is already given. Initial volume is what? 10 decimeter cube. It is given. Final volume is what? 20 decimeter cube. That is given. Temperature is also given, but it is given in degrees Celsius, which you have to convert it into Kelvin because Kelvin is SI. So how do you convert it? Plus 273. So 27 plus 273 will give you 300 Kelvin. So temperature is also given. R value is already given in the question. Okay, so now you just have to substitute in this equation. So you will get minus 2.303 into N. N, it is given 1 mole of a gas. So N value is 1. Now what is the value of R? It is 8.314. What is the value of T? It is 300 log 20 by 10. V2 is what? 20. V1 is what? 10. So 20 by 10, what is 20 by 10? It is 2. Now what is log 2 value? It is 0.301. Okay, so it is important to remember this value of log 2, that is 0.301. So 2.303 minus 2.303, and it's very important to remember this minus sign also. Okay, into 8.314 into 300 into log 2 value is 0.301, which will give you minus 1729 joule, which you can write in kilojoule also as minus 1.723 kilojoule. So it is a very simple numerical. You just have to remember what is the equation for work done for an isothermal reversible reaction, that is W is equal to minus 2.303 nRT log V2 by V1. Okay, so I hope it is clear. Moving on to the next one. Calculate delta G naught, that is standard Gibbs free energy, for the hydrolysis of sucrose. The equilibrium constant Kc is 2 into 10 to the power minus 3 at 300 Kelvin. So just seeing a hydrolysis of sucrose, don't get scared. Kc value is already given, that is equilibrium constant value is already given. You just have to calculate delta G naught value. So there is a equation which directly gives you a relationship between standard Gibbs free energy and equilibrium constant, which is the equation delta G naught is equal to minus RT ln Kc. Okay, so if you know this equation, you don't have to worry about the hydrolysis of sucrose, just you have to substitute the values. So what is that you have to calculate? Delta G naught you have to calculate, right? So now what is R value? R value is already given in the question, that is 8.314. Okay, so minus 8.314 into what is R value already written, what is T value? Temperature is given as 300 Kelvin, so it is already given in Kelvin, so use 300. Now ln Kc. Now what is the value of Kc? 2 into 10 to the power minus 3. So ln 2 into 10 to the power minus 3. So if you calculate it, you are going to get minus 7.64 into 10 to the power 4 joule per mole. Okay, so this is the value of Gibbs free energy, standard Gibbs free energy. So this is also a very important equation. Delta G is equal to minus RT ln Kc. So directly you can substitute, get the answer. So I hope it is clear. So now moving on to the last question of the question paper. The reaction between nitrogen and oxygen take place as follows. 2 moles of nitrogen combines with oxygen to form 2 moles of nitrogen oxide, N2O. If a mixture of 0.48 mole of N2 and 0.933 mole of oxygen is placed in 10 liter vessel and allowed to form N2O at room temperature, at which Kc value is given 2 into 10 to the power minus 37, determine the composition of equilibrium mixture. That means you have to calculate the molar concentration of what is formed here, N2O. Okay, that is what you have to calculate. So how do we start this? The equation is already given to you. What is the balanced chemical equation? 2N2 plus O2 gives 2N2O. Okay. And the number of moles of each of this is given. If a mixture of 0.482 mole of nitrogen and 0.933 mole of oxygen, it is given here. So, initially, that is before it attained equilibrium, initially what is the number of moles is given here? That is 0.482 moles of nitrogen and 0.933 mole of oxygen initially. So, initially is there any N2O which is formed? No, right? Okay, initially only reactants will be present, products won't be present there. So, the number of moles of these two is already given. For N2O, we don't know. Okay, so as you can see, 2N2 plus O2 giving 2N2O. So, initially before attaining equilibrium, what is the value you can see here? 0.482 and 0.933, and here nothing is formed because the product is not formed initially, right? Now after a while, okay, after the reaction has proceeded and it attains equilibrium, now what happens? After the equilibrium is attained, what happens? X amount of N2O is formed. Let us assume that X amount of N2O is formed. Okay. So, if I am considering at equilibrium, X is formed. N2O, if I am considering X is formed, how much it will be reduced from here? 0.482 minus X it has reduced. 0.933 minus X it has reduced. So, how much it has reduced, that much it will be formed there, right? At equilibrium, this is what is going to happen. So, that is what is mentioned here. Minus X and minus X by 2. So, this is important, X by 2. I have not mentioned it there. What does this X by 2 stands for? As you can see here, 2 moles of N2 is here, but only 1 mole is here. So, what you have to do, you have to divide it by 2 here. So, that much, whatever it has reduced, that much it has increased in the product side. Okay. So, this much, I hope it is clear. Now, moving on to the next part. As K value is given in the question already, 2 into 10 to the power minus 37. It's minus 37 means it is a very, very small value, right? So, this means that the amount of nitrogen and oxygen reacted, that is X, is very small. Hence, at equilibrium, we have N2 and O2 values which is given. That means what? As you can see, at equilibrium, what did we discuss now? X amount of N2O is formed, and this value 0.482 minus X is that is minus X is being reduced, and here also minus X by 2 is being reduced, right? So, if that is the case, what do we have to do? This X value will be very, very less because the equilibrium constant is a very less value. So, we can just ignore this X. So, what will be the molar concentration of N2? It will be 0.0482 and molar concentration of oxygen will be 0.0933. Okay, and what will be the molar concentration of N2O which is formed? It will be 0.1x. So, from where did I get this? So, the molar concentration. So, till here we have discussed. Now, molar concentration we have to divide by the whole equation by 10. So, what happens here? You get this, here you get this, and here it will be x by 10. Okay. So, what happens here? X it has reduced, right? X it has reduced means what happens? It will be and we discussed that as the Kc value is very, very less, this X we do not have to consider. So, what is the molar concentration of nitrogen? It will be 0.482 divided by 10. Here it will be 0.933 divided by 10, right? So, that are the concentration because we are not considering the X value because it is very, very small. But in case of N2O, we do have to consider this X, right? So, it is 1 by 10x, that means 0.1x. Okay, so that is what is given here. So now we can calculate the equation for Kc. What is the equation for Kc? How do you calculate? It is the product of molar concentration of the products raised to their powers divided by product of molar concentration of reactants. So which is the product here? From this equation N2O. What is the molar concentration of N2O? It is given 0.1x. So 0.1x square. From where did that square come? What is the number of moles? 2, right? So that 2 we have to take in the power. Divided by, already discussed what is the molar concentration of nitrogen? It is 0.0482 square. Now again from where the square came? See, there is 2 moles of N2. And oxygen there is no square because the number of moles is just 1. Okay, so now this value will be equal to 2 into 10 to the power minus 37. Kc value is already given in the question. So this is equal to 2 into 10 to the power minus 37. So when you calculate this, we are going to get x value as 6.6 into 10 to the power minus 20. So once you get the x value, you can calculate the molar concentration of N2. What was the molar concentration of N2O? It is 0.1 x, right? So 0.1 into 6.6 into 10 to the power minus 20. If you do, you're going to get the value as 6.6 into 10 to the power minus 21 mole per liter. So this is the molar concentration of N2O. So this is how you have to do this equation under equilibrium. So equilibrium is a very important chapter which carries the most weightage. So it is very important to study these type of numericals. So by this, we come to an end to the discussion of model question paper of 23-24. So I hope all the questions that we have discussed, that is from part A to part E, it is clear for you. So I wish you a very good luck for your upcoming board exam. So that's all for today. Thank you.